Hi, in this session and next few videos, we are going to talk about several sorting algorithms. So before we get into what are the different kind of sorting algorithms, let's first try to understand what is sorting and why do we need sorting. So let's first talk about what is sorting. So if you have a laptop, which you must be having, or a computer, you will see that there's an option at a place where all your files are stored. There's an option to sort your files by size, by date modified, or by date created. And in that also you have an option that you want to store it in descending or ascending order. So at the end of the day, sorting is nothing but arranging your elements in a particular format. Okay, either in increasing or decreasing order. So what happens is that, let's say we have few elements. We have 32, we have 48, 23, 52. So now as you can see that these are few numbers, and in this particular case these numbers are not having any particular order. Now you can think of this as a list, as an array, or anything. Now let's say what I do is that I arrange them. So let's say I put it this way: D2, 48, 50. So I have arranged them in increasing order, or I can arrange them in decreasing order as well. Let's put it 8, 48, 50, 48, 32, 23, 2. So now you can say that this is an unsorted list, this is a sorted list, and this is also sorted. This is sorted in increasing order, this is sorted in decreasing order. So this is what sorting is. Sorting is to arrange a set of elements in a particular order. So now what will happen is that all the sorting algorithms that we will see today, we will be majorly seeing them on arrays. So all our elements will be stored in an array, and we will see how we can put our sorting algorithms or apply our sorting algorithms on that. Okay, now the question is, why do we need sorting? So what happens is that, let's say in this particular case, you have to find out which is the highest number. Okay, so what you will do is that you will go through each and every number and find out that which is the highest one. Now let's say if you are already given a sorted array, in that case what will happen is that you don't have to go to each and every element. You just know that the last element is the sorted one. In case it is arranged in decreasing order, the first element is the sorted one. So this is one use case. So majorly we do sorting to optimize the operations that we are going to perform on the elements. Okay. Another use case of sorting you must have seen in binary search. So we just saw in previous set of videos is that in binary search, we need the arrays should be sorted. And if we don't have sorted array, the other algorithms gave us time complexity of O of n. Okay, and binary search was O of log n. And this was happened just because the array was sorted. So what will happen is that as you go ahead in coding, many times just by sorting the array, the problem statement will be easier to solve and it will be optimized as well. Okay, so let's go ahead. So before going into sorting algorithms, let's just see few classification of sorting algorithms. So basically sorting algorithms are classified on certain basis. Let's see what is that. So first one is comparisons. So there are two kind of sorting algorithms. Number one is comparison based. Number two is non-comparison based. Comparison based algorithm you can think of as bubble sort, merge sort, insertion sort, selection sort. Non-comparison algorithm is counting sort. We are going to talk about all of these algorithms. So basically comparison means that if we are sorting the algorithm based on comparison between two elements, then in that case it's a comparison based algorithm. So basically there is a key and we do certain comparisons to decide that how do we sort the array. Now second one is swapping. So basically another criteria to see or judge a particular algorithm is that how many times swapping is happening, and this is also known as inversion count. And there will also be a question around inversion count as you go ahead. Now the third one is space or in-memory sorting. Okay, let's call it in-place sorting. So in-memory sorting is different sorting. What happens in in-memory is there are two kinds of sorting: internal sorting and external sorting. Internal sorting generally takes place in main memory, and external takes place, you need some external device for that. And this is different. This is like if you are given an array, do you need extra space to sort the array? If yes, then obviously that is not in-place sorting. If it is, you are using the same array, maybe some constants, and you are trying to sort the array in the same space, that is in place sorting. Okay. Apart from this, we have time complexity. So different sorting algorithms have different time complexity. We are going to see that. And then we have recursive sorting or iterative sorting. So some of the recursive sorting are going to be merge sort. And let's say insertion sort is not a recursive, that is iterative. We have quick sort. And then we have bubble sort, insertion sort, we have selection sort, that is going to be iterative. So one more thing that is there is the stability. So there are actually 6 points. Okay. So stability means that, let's say we have something like this, 1, 1, 6, 2, 2. So when we say an algorithm is stable, which means that in the resultant array or the sorted array, if this 2 is coming first in the original array, then this 2 will be coming first in the sorted array. Basically, if the sequence of elements is preserved, and this happens generally with the same numbers. So if these two are same numbers, these two are same numbers, so generally what happens is that in these kind of algorithms, we don't take care of the sequence of these numbers. But in some algorithms like counting sort, what happens is that if 2 is appearing first in this particular original array, then it will appear in this particular array as well. So these are the 6 basis on which, these are the 6 criteria on which generally I'll say algorithms are judged or algorithms are classified. Time complexity is still somewhere you will find time complexity in the real list, somewhere you won't find the time complexity, because time complexity is a major factor and it works on almost all the algorithms. But these 5 are something that classifies an algorithm. This is not a very, I'll say, hard and fast classifications. These are just a few criteria to judge an algorithm or to, I'll say, analyze algorithms. Okay, let's just go ahead and see the algorithms one by one.